See if the mic works. It does. All right. Hello, everyone. My name is Doug Moe. I'm a longtime journalist here in Madison. I want to thank you for coming to today's Wisconsin Book Festival event, co-sponsored by the Wisconsin Science Festival. And it features Jim Lattis and Kelly Tyrrell and their fascinating book, Chasing the Stars. We want to salute the Madison Public Library, the Madison Public Library Foundation, the Science Fest, and all the sponsors for helping make this celebration possible today. Lake City Books is selling books. They have a table out to the left if you exit that way. And Jim and Kelly will be signing after their presentation today. They'll speak for about 30 minutes or so, and then we want to open it up and leave plenty of time for audience questions. Last, I'll ask you to silence your cell phones so as not to interrupt anything. I'm very pleased to welcome Jim and Kelly and look forward to their discussion on a subject I think most of us find endlessly interesting. Some years ago, I did a magazine profile of UW astronomy professor Eric Wilcox. And as an English major, I at one point asked him the amateur's question. I said, "Is there life out there in the universe?" "Absolutely, yes," Wilcox replied. And I think my jaw might have dropped because he then said that for a long time, most of life on Earth was bacteria. And then he kind of grinned and looked at the sky and said, "I'm pretty sure there's bacteria out there." Chasing the Stars documents how Wisconsin astronomers have influenced our understanding of that universe, and what a compelling subject that is. James Lattis holds a PhD in history of science from the University of Wisconsin-Madison. An author, professor, frequent public speaker, Lattis specializes in early modern astronomy and the history of Wisconsin astronomy. Lattis has directed UW Space Place since its founding, helps manage the historic Washburn Observatory, and consults widely for the media. Kelly Tyrrell started out as a cellular and molecular biologist before becoming a science writer. Her work has given her a front row seat to many astronomical innovations, including a 2017 visit to the Southern African Large Telescope. Today, Kelly oversees media relations for UW-Madison and is an editor for the science journalism nonprofit, The Open Notebook. Please join me in welcoming Jim Lattis and Kelly Tyrrell.
Thank you, Doug, and thanks for the welcome here for the Science Festival and the Book Festival. You're going to hear from Jim first.
We're gonna switch off. About the first half will be me, and then the second half will be Kelly. So thanks so much for inviting us to be here at the Book Festival and the Science Festival. It's really cool to have our book featured here, and it brings around a topic that's relevant, of course, really important to science at the University of Wisconsin, which is one of the reasons why we wanted to write the book. We're going to focus today, as the title said, on some specific topics that we address in the book, specifically women who've contributed to the history of Wisconsin astronomy. But I want to sort of set the stage. The book covers more than that, including things on the science that was done at the observatory and the scientific heritage where the work at Washburn Observatory led. So to set the scene a little bit, always my first message is don't forget the Washburn Observatory is open to the public. That means you, on the first and third Wednesday nights of each month, and that's been the schedule since 1881. So you've missed many opportunities already if you haven't been there. Actually, sorry, the dome was broken over the summer, but it's now back in operation. We're back in operation, first and third Wednesday nights. Well, the observatory, why do we have this observatory? Well, the name tells you, Washburn. It was built for the university by a guy named Cadwallader Washburn, who was a very wealthy Wisconsinite industrialist. He had made lots of money in lumbering and flour milling and things like that, and then decided he wanted to give a gift to the university, and having observatories was a status symbol. I suppose it still is today, but in those days, very much having an observatory was a status symbol for a university and an indicator of the pretensions of the University of Wisconsin under John Bascom to become a research university. And Washburn Observatory is the first research establishment on the university campus. Over the years, it measured up many important astronomical projects were carried out there in a variety of different settings. There was, in the early days, which means 1879 and onward there. In the early days, it was very important. It was really a world-class observatory in what we now call positional astronomy, what they have just thought of as astronomy, which involved particular kinds of science. But then in the early 20th century, the Washburn Observatory became one of the sites of the development of modern astrophysics, a sort of qualitatively different enterprise, still related in studying the heavens, but very different methods and very different technologies. So the foundations of astrophysics were laid right up there at the Hill in the early 20th century and gave rise then to we have a world-class astronomy department still today. The astronomers who worked in that period, and we're at first, at least, we're talking about mostly in the 19th century, the astronomical staff, I guess I should say, was sort of divided into the professional staff, the astronomers who were expected to have had some training, some professional training of sorts. PhDs were still rare in 1879, PhDs in astronomy. There were like 2 in the United States or something like that. But those astronomers were doing observations at the right at the telescope, eyeball at the eyepiece, as I like to say. And the work, the measurements that they made looking in those eyepieces were written down in notebooks, longhand. And that work in the notebooks, that's raw data that they're getting from their measurements that they're making at night. That kind of stuff has to be dealt with. And that's the other part of the observatory staff that we're going to talk about, what are often called the computers. The observers weren't always doing exactly the same thing. It depended, of course, on the research that they were doing. Here at Washburn, it was very much eyeball at the eyepiece. I'm going to refer a number of times to what was going on at Harvard for a couple of reasons. Harvard, at that period, the observers, that's very early in the use of photography in astronomy. The observers at Harvard were doing photography, early astrophotography for a number of different purposes and by some other methods. So there, the observers were doing that. We're still going to talk about the staff that they had working behind them as well, the daytime staff, the computers, often women. So the computers, the other half of the observatory staff, you had your observers, who were almost always men, and then you had your daytime staff, the computers, because there's always some kind of data reduction to be done after the night's work of observing. The computers were typically staff that were more thought of as sort of interchangeable staff. You just needed some, and they were going to put in a number of hours for you. And the general idea was that you could train a computer to do the work that you needed. So they were not required to be professional staff. They didn't have to have a professional background in astronomy, and in fact, most did not. Now, again, looking up at Harvard, they were doing stuff with photographic plates in the daytime. The observers during the daytime were looking at photographic plates, and they're famous for this, and looking at very early stellar spectra and classifying the stellar spectra. So they were really more classifiers than computers, but they were still called computers up there at Harvard. And there was actual computation work to be done in those days as well. There were some at Harvard who then became very important astronomers. Annie Cannon is an important one, for example, who really sort of transcended that role and became professional astronomers in their own right. So transcending this interchangeable worker sort of role. At Wisconsin, the typical computing work really was computing. Here's an example. This is a spreadsheet. And by the way, there's one over there. I brought a spreadsheet from our collection on the table if you want to look at it afterwards. This is what spreadsheets look like for actual human computers, actual paper spreadsheets. This involved taking the observations that you see down one column of this page and then doing arithmetic operations on them in order to transform them into something more useful. In this case, going from readings from the telescope and into a celestial coordinate, the actual, what's called the declination, the actual north-south location of an object in the sky. So you can see there's a lot of numbers, a lot of writing, and the number up in the corner tells you that that's number 353. They did thousands of these sorts of things. You can only imagine how much human labor is going into this kind of work, and they weren't using calculators to do the computing either. They were doing it by hand or maybe with log and trig tables, occasionally slide rules, that sort of thing. Computing machinery was extremely primitive. It could add and subtract. That's about all that a computing machine could do in those days. So here you see an example of the kind of computing going on in the daytime. The night's work would give you that first column there, and then from there on the calculations go on. So what were they doing? What were they actually creating? Well, in that particular spreadsheet, for example, coming up with an actual coordinate on the sky, that would have been part of creating a star, basically a star catalog, the determination of places of stars to an accuracy appropriate to whatever the research was that was involved. Other sorts of measurements went to identifying stellar parallaxes. Again, a creation of a calculation based on an observation. Stellar parallaxes are really important because they gave you distances to stars. Other kinds of observations at the telescope were of binary star systems. And by repeated observations of those, we can eventually get things like the masses of stars. So we can begin to learn about the nature of these stars that are out there so far away. And then another form of measurement, all these things were going on at Washburn Observatory, were what were called proper motions of stars, the apparent motion of a star across the sky. And measuring those in sufficient number began to provide information about distributions of stars in what we would ultimately call galaxies. That term wasn't used that way in those days, but the stellar universe, they would often talk about the stellar universe. Okay, so hardcore calculations here at Wisconsin. Just to go back to Harvard briefly, there's a plate of stellar spectra dating from those days at Harvard. And each one of those little bars there is actually a stellar spectrum. And those notations on there are telling you what type of star, what spectral type of star they've concluded by studying that spectrum there. So those computers are looking at these things in the daytime, studying those stellar spectra, coming up with the classification system, and ultimately classifying hundreds of thousands of stars, spectral types of stars. Another important bit of work going on at Harvard was in a completely different area, looking at a type of variable star and coming up with information about a type of variable star that allowed them to be distance indicators, what are called Cepheid variable stars. I keep coming back to Harvard in part because it's a very useful comparison to play off against the type of work that was going on here at Wisconsin, but it's also nicely documented in a book by Dava Sobel called Glass Universe, which I notice is on the table right outside there, and then Dava will be giving a talk right here after we're done. So Dava has sketched this activity of the women at Harvard, really going up into about the 1920s. And it makes a really nice comparison for us to play off the Wisconsin work again. So Kelly will take over from here.
Now we get to meet some of Wisconsin's female astronomers. And they're among the ones you meet in the book Chasing the Stars for anybody who is interested in more after today. So back in the 1880s, when Washburn Observatory was becoming established, the norm of the era was that observing was not for women. Women were not suited for, quote, the physical hardships of observing because it meant long nighttime hours over a telescope. At UW, President John Bascom, however, believed in welcoming women into academic life. He believed in equal access for men and women in educational spaces. Quick fun fact, his daughter, Florence Bascom, earned 2 bachelor's degrees from UW-Madison, her first in 1882 and her second in 1884. And she became the second woman in the U.S. to earn a PhD in geology and the first woman to earn a PhD from Johns Hopkins University. So just a little bit of interesting tidbit there. Bascom really believed in this equitable access. And so he was welcoming women into UW-Madison as well, and some of those women were interested in working in astronomy and got jobs at Washburn as computers. Computers were really important, as Jim walked us through in that era, because many observatories, including our own, wouldn't have been able to convert all of that interesting observational data into useful scientific results, which they then would publish at first in internal publications, including here at Washburn, and then ultimately as journals became more prolific as a way of scientific sharing in those venues as well. Most calculations, as Jim worked us through, were performed by hand. Two of the women you are about to meet, when working with the second director of Washburn Observatory, Edward Holden, they were working on a star cataloging project using data from the U.S. Naval Observatory. And Holden estimated that these two women would have written somewhere between 3 and 4 million digits in their 2 years working on the project. So incredibly important contributions these women were making. It's important to note that not all of the computers were women. There were also male computers. We don't have stories on every student and every individual who worked as a computer, but Jim and I are really glad that we were able to find some of these women's stories in particular to share with you. And I really like this quote that we included in the book from Joel Stebbins, who later became director in the 1920s. But he said that women's skills are equal to men's, except usually the women are neater and just as accurate. And if you have a chance to check out that spreadsheet, I believe it's an Alice Lamb spreadsheet, and it is quite neat. Just want to reiterate that we don't know a whole lot about every computer or every woman, but we've done our best to compile the stories that we could find. By and large, the students were recruited from Edward Holden's astronomy classes, and they were employees making 25 to 50 cents an hour. Sometimes they were offered lodging. We'll talk a little bit more about that in a minute. And most of the student assistants were funded from income that came from Washburn Observatory's time service. This was something that observatories could do for banks and railroads, really industries in the US that needed the most accurate accounting of time possible, and where better to get them from than from observatories keeping celestial time. So one of the female computers we know of from this era is Emma Gattaker. She started working with Edward Holden, the second director, in 1881, again on this project to catalog sections of the southern sky, cataloging stars. We know Emma was from Baraboo. She earned a bachelor's degree in science, very descriptive, in 1881. She was working in the summer of 1883, making $20 a month, and was given upscale lodging in the observatory residence. Meanwhile, her male counterparts were earning a little bit more, but were sometimes relegated to the really dismal confines of the solar observatory and the student observatory. We also know that Emma had some impressive German skills, and her skills were put to work understanding astronomical lenses and some of the physical practices at the time. So what were women like Emma doing? They were transferring the observational data into notebooks, from the notebooks into spreadsheets. They would have been transforming raw data into celestial coordinates, plotting star charts, and publishing in star catalogs, among other things. Working alongside Emma, we know, was a woman named Elizabeth Schofield and Alice Sanborn. Elizabeth was from Wausau. She also earned the illustrious degree of science in 1881. And she and Gattaker were the ones who were writing those 3 to 4 million digits back in those days. We also were able to uncover the story of Alice Sanborn from Freeborn, Illinois. She got a bachelor's of letters in science, transforming to today's degree in 1883, and she also got a graduate degree in English literature in 1886. She was also involved not just in computing, but in working with one of the instruments, the meridian circle. I think Jim touched on a little bit, but was a really important instrument in this era at Washburn Observatory and factored into a lot of scientific innovation and progress at the time. Alice also was able to write up results for publication in the publications of Washburn Observatory. And she wrote and won an essay for something called the Lewis Prize. And it was a prize put on by a student organization. And allegedly, she talked about the telescope in this essay about ambition. We have not seen the essay, unfortunately. Otherwise, we'd be sharing it with you today. But clearly, her work at the observatory was meaningful enough to her that she went on to write this essay that she won awards for. She was also publishing under her own name, which would have been, relatively unusual in that era. Alice Lamb is probably my favorite. If I knew her today, I would hope to be her friend, I think. Like Sanborn, she was also publishing under her own name. She earned a Bachelor's of Letters here and then a Master's as well. She was right here from Madison, together with another student assistant named Milton Updegraff, who would be her future husband. They were serving as the last student assistants with Edward Holden before he left for a new gig at Lick Observatory in 1885. And it was actually the two of them, Alice and Milton, who kept the observatory running in those years in between and were really responsible for the scientific progress made in those years. Basically, together they published volume 4 of the publications of Washburn Observatory and produced the only significant research results in that period. What's also interesting about Alice is that, unlike many of her female counterparts, she was actually permitted time at the telescope. And she also ran the university's time service. She was cited by Sherburne Burnham, who amassed an extensive catalog of double stars in his 1900 catalog. So she was making a lot of contributions in the region, in the space, in her time. She was offered a position as an astronomer, again, unusual in those times. She was offered a role running a small observatory in present-day Yankton, South Dakota. I have never been to Yankton. Has anybody ever been to Yankton? Okay. But her husband's work brought him to Cordoba, Argentina, where she followed and briefly had charge of the time service there for the National Observatory. But when he came back to the U.S. to take other roles, her work in astronomy appears to have faded. And I love this quote that Jim was able to find in the archives. It's here under her photo. But she says she refused the offer in South Dakota because she would far rather work in a true observatory than direct a toy one, and partly because she felt compelled to stay. We learn more about Edna Hill, who worked with astronomer Albert Flint at the observatory for many years. Flint was a pro with the filar micrometer and the meridian circle, and he was doing a lot of painstaking work measuring stellar parallax. I think he took something like 29,000 measurements in maybe a 5-year period, so it was prolific. But Edna was working closely with him, helping interpret the electric marks, the electric signals. There would be a mark on a page, and she was manually entering and measuring those marks to help ensure that there were publishable results. Later, at the just beyond the turn of the century, there were other observatory staff computers who followed. And interestingly, in 1932, we had at least one female graduate student. Her name was Aletta Esther Badeau. In the book, we share a number of limited details that we've learned about her, but unfortunately, her record seems to be lost to time for now. Does anybody know what this machine is here on the bottom? Has anybody seen that before? Well, if you'd like to see it, this very one sits at Washburn Observatory, so if you come to the observatory, you pay to visit. But it's a 1950s era calculator, so the computers in this period would have at least had the benefit of a little bit more advanced technology. And the work that computers were doing were evolving as the technology advanced. A little bit later, here around 1960, we had Edith Flather. So speaking of evolutions in technology, Edith was an early programmer. So she was working with electronic computers and helping transform and work with data to create mathematical models to help advance astronomical understanding. But she was by no means the only woman since. By the early 1960s, women accounted for 1 in every 4 astronomy grad students at UW-Madison. And by 1966, Washburn employed its first PhD astronomer who was a woman, and her name was Betty Louise Webster. She came to Wisconsin from Australia. She wanted to advance her research studying planetary nebulae. There was a quote that we were able to track down for the book from the Capital Times from 1967, and I will read it to you. It is, "Astronomy presents no special handicaps for women, least of all observations with big telescopes, as Miss Webster sees things." Thankfully, today we don't talk about female astronomers or lady assistants or female computers. Women are much more prominent today, and today they actually constitute about half of all PhDs awarded in the United States in astronomy. And I was privileged to help work on a story earlier this year with one of our own, Melinda Suarez Furtado, who earned her PhD here in 2020 and has come back as a faculty member. And she was engaged with a team of other young female astronomers here at UW, but we can just say astronomers who happen to be women. They discovered a large star with an Earth-like mass orbiting it. So thankfully, women today are making a lot of contributions in astronomy. And it doesn't have to be notable. So with that, we have tons more stories in Chasing the Stars. We hope if you haven't yet, you'll pick it up and read it. Go to the library. I just saw it in the wild in Spring Green in the Arcadia Bookshop, so that was exciting to see. But I think Jim and I are happy to take questions.
Good afternoon. I wondered if there was any contact or collaboration between Washburn and the observatory at Harvard.
Sorry, did you say the observatory at Harvard?
Yes.
Is that what you said? I can't think of anything I would call collaboration. They were they certainly knew each other's work. Those are the early days of the in the late 1890s. The American Astronomical Society began under a different name. So they were aware of each other's work by regular conferences and things as astronomy got professionalized, you might say, in those days. But no, I can't think of any particular collaborations between the Harvard group and the Wisconsin astronomers. They were doing very different sorts of work. The science begins to converge with work at Harvard and work at Wisconsin in the 1930s, and there's some very interesting stories about the way that the efforts of Wisconsin astronomers and Harvard astronomers were actually coming to different answers about what the stellar universe was like, and so that leads to some interesting an interesting confluence of views that produces the modern view of our galaxy. But no, in that early period, I can't think of any sorts of collaborations.
Thanks. It's a nitpicking question that has nothing to do with astronomy, but this Sanborn, you said she was from Freeborn, Illinois. I don't think there is a Freeborn, Illinois. There's a Freeport, Illinois, which produced a number of distinguished women, including Jane Addams from nearby. but are you sure it's not Freeport?
You're probably correct. You're
No.
an astute reader. No?
I'm not sure. I'm not sure either. I saw that and thought the same thing and thought I really ought to go double check that, but I couldn't tell you that there wasn't a Freeborn in those days either. So
Yeah, and I just looked it up, and I think they might have mentioned it if there had been one. But I want to give credit to Freeport, Illinois, because I live right down the road from it, and it's a very energetic, very old city that had a lot of, as I say, distinguished, accomplished people. So if it is Freeport, and I'm thinking Sanborn, Freeborn, maybe there was just a little.
It was probably a typo on my part. Yep.
Yeah,
Kudos
please
to fact checkers.
untypo it. Thank you.
Yes, and everybody go visit Freeport. Sounds like a lovely place.
Did the election of Robert La Follette as governor in 1900 and progressives in the legislature and as governor subsequent to that have any impact on the work that was done at the observatory?
around 1900, not that I can think of. Robert La Follette and George Comstock, who was the director until 1920, were classmates at Wisconsin, and La Follette began his political career just as as the Washburn Observatory was getting organized as well. The state provided funding. There was in fact, this goes back to, this is in the book. Washburn actually arranged for this, that the legislature was required to provide $5,000 per year for the support of astronomy at the university, on the condition that somebody donates an observatory to the university at no cost to the state. So Washburn had himself in mind as the donor, and then got the legislation passed to provide then that institutional support. The observatory then funded itself also with the time service, and as far as I know, that $5,000 allotment wasn't changed over the years. I think they were still getting $5,000 in 1900, just as they'd been getting in 1879. But no, I don't know of any change that occurred because of that. In fact, the university expanded the astronomy department by adding a faculty member at about that time. So we had 2 astronomers instead of just the one. But I think that was internal. I don't think that was a state thing.
It's actually one of my favorite things that I learned in working on this book is that Washburn Observatory is the first public-private building on the UW-Madison campus. For that reason, it was funded by a donation from the governor, but built into the state legislature for funding.
Former governor.
Yeah, former governor. Yep.
Yeah.
I'm interested in knowing concerning the time service aspect of the work at the observatory. You were determining this is a question by somebody who doesn't know much about astronomy. So, were the astronomers determining time by the celestial? By the position of the stars? Were they relating it to Greenwich Mean Time? And did Greenwich have an observatory as well?
Well, certainly Greenwich had an observatory as well. Yeah, it was a very common role for observatories to determine the time, to do time finding, by typically by star observations. That was the most accurate way to do it. You use your meridian circle telescope, for example, to observe the transit of a star, and you can turn that into an accurate time. That time had various applications. Greenwich was very important, for example, to the navigators, the ship owners and ship captains in sight, and they would at noon the ball would drop up on Greenwich Observatory, and navigators set their chronometers before setting sail from a signal like that. By the time the Washburn time signal was time service rather was active, telegraphy was the way to distribute the time. So a telegraph signal would go out. So there would be a master clock. There was a master clock at the observatory that was set astronomically. Ideally daily, that is nightly, they would do an observation to set the master clock. But if it was cloudy that night, the clocks were usually accurate enough that it wouldn't be too far off for several days. You could go maybe 3 days without doing an astronomical sighting before you started to worry too much about it. They would set the master clock. The master clock would automatically send a time signal at, usually it was 10 a.m. on weekdays. Sundays, the clock didn't send out a signal. And subscribers to the time service, which included railroads, but also businesses and a few other places, would switch their telegraph line in to the observatory line shortly before 10, and they would hear a series of ticks, and then it would skip one, or maybe it skipped two, and then the next tick would be the first one on the hour. You set your clock to that. So they paid for that service. That was, as I say, the Washburn Observatory did that, but there were a number of others who generally provided sort of regional kinds of coverage. So the U.S. Naval Observatory was, of course, doing it for the reasons that Greenwich was, as well as for the type of services that also wanted time signals. All the major regional observatories were doing that kind of thing. St. Louis University was doing it. The observatory at Carleton College in Minnesota pretty much dominated that service for Minnesota and the surrounding region. In fact, at one point there was a little bit of a exchange of letters where they had to kind of agree that we wouldn't sell services across the Mississippi if they wouldn't, so that we had our own sort of zones of influence. So that was a major source of income for the observatory for a few years there. It was roughly brought in money that was comparable to the amount of money that they were getting from the state, which allowed them to employ observing assistants and computers and improve their equipment and things like that. So in the early days, it was a really important part of the life at the observatory.
Thanks. How about interactions with Yerkes? What sort of division of the observational pies did they make?
Well, so Yerkes came along in about 1896, so considerably later than the origins of Washburn, and was established by the University of Chicago with funding from Charles Yerkes, hence the name, of course. Yerkes was doing research in early positional astronomy that was similar to what was going on here. But the patterns of astronomy were shifting by the 1890s quite a bit. They, for instance, at Yerkes, they built a section of the observatory for a meridian circle, which they then thought better of and never installed in there. The meridian circle was already becoming questionable in its utility to astronomy. They started doing early astrophysical kind of thing, photography. They were doing photography for what's called astrometry, for star position measuring, which is what the meridian circle was doing as well. And they did early experimentation with spectroscopy, which was also an important part of early astrophysics. The two observatories, that is Washburn and Yerkes, were always in close communication. And there's a lot of back and forth between the two, and just in terms of personnel, but also in scientific conversations and in coordination of things. So, for example, people would write to Comstock and ask for Flint's latest parallax results on a star of interest there at Yerkes, where they weren't doing that kind of work. Became even more closely, the two observatories became more closely collaborative in the 1920s when Joel Stebbins, who was Comstock's successor, started developing photoelectric photometry here and producing good science with it. The first observatory to ask for a copy of Stebbins' photometer was Yerkes, and he built one specifically for Yerkes, and then trained their astronomers to use it. So there was a good bit of common activity between the two. Meetings were hosted sometimes here, sometimes there. The beginning of the American Astronomical Society was, well, you can Harvard and Yerkes can fight it out about that, but it started at one of those two observatories, depending on which you call the first meeting of the society there. And at the Yerkes meeting where they agreed to write a set of bylaws, George Comstock was delegated to do that, and so he wrote the bylaws for the first set of bylaws for the American Astronomical Society were written in the study up there at Washburn Observatory, and then probably approved at the Harvard meeting that came right after that. So there's a fair bit of back and forth, and much later too, right into the 1950s. In fact, there's some very important work in the 1950s between the photometry specialists up here and the specialists, the spectroscopic specialists. W.W. Morgan, for example, at Yerkes worked closely with Albert Whitford here at Wisconsin in those days as well, coming up with some of the first evidence for the spiral structure of our galaxy. So all the way along, there's been important connections between the two.
And Yerkes is a place you can still visit, and it's really a beautiful, beautiful spot in Lake Geneva.
I'm just wondering when Washburn Observatory was last updated, and does it have any functionality for research these days?
No functionality for research these days. I one time talked to a guy who was thinking about a new type of detector, a guy in the physics department, and he said, could we put it on the Washburn telescope? And I said, that would be really cool. But he never did. He must have used a different telescope, or maybe that technology went nowhere, I'm not sure. So no, since the mid-1950s, up until the mid-1950s, maybe is the way to put this, Morse Huffer was still doing binary star measurements, photometry of eclipsing binary stars on the Washburn telescope. But 1958, the university built a new observatory for the astronomy department, Pine Bluff Observatory, which is about 20 miles west. And that has a bigger telescope, a 36-inch reflector, and all the research moved there. So it really hasn't been relevant to research. So education, public outreach have been its primary functions ever since.
And some of that has to do with the amount of light pollution, right? We don't get a lot of visibility in a city like Madison, given how many lights there are. Most observatories these days are located high and dry. So they're remote, they're in high deserts, they're located away from population centers. So Doug mentioned at the outset that I, in 2017, went to the Southern African Large Telescope. UW-Madison is a consortium partner to keep that telescope running to serve national interests, but also scientists in South Africa. And to get to that telescope, we had to fly to Cape Town and then drive 5 hours into the desert. And there's nothing around it, and it makes it a really great location for study. And also these days, most astronomers aren't doing observational science. They're doing astrophysics. They're relying on operators who have instruments, either Earth-based instruments or space-based instruments tuned into objects of interest. And so most of the science is done through. Most astronomers don't even go to these observatories anymore, right? They don't look through the telescopes. They're getting their data in a data dump in a CSV file from those limited times they get time to point the object where they want to point it. But it's we certainly needed these telescopes to pave the way.
Yeah, the only there is a research telescope on campus, but it's a radio telescope, not a
Two questions. What's the oldest Western observatory in the upper Midwest? And were there any indigenous people involved in any way with Washburn?
Michigan is the oldest one. In the upper Midwest, I think Michigan must have
Dearborn,
been the first
right?
one.
Yeah.
The Dearborn Observatory. Yes, at Ann Arbor, the
Not
University of Michigan.
Dearport.
Thank you. Yeah, not Dearborn. Right. Yes, the at Ann Arbor, the Michigan Observatory was, I think, the 1850s. The date is not right on at the top of my mind, but I think that would be the first one. Could be wrong about that. Native American involvement, well, the only connection that I can bring up, and we bring this up in the book, is that the Washburn Observatory was built on a site that was clearly favored by Native Americans, the mound builders specifically. And so so the Washburn observatories were not the first stargazers on that hill. But no, I can't think of any involvement of Native American people in the early history of Washburn Observatory or now, or the Detroit Observatory,
For now,
the
for now.
Michigan Observatory.
Yeah, and really the only mention in the historical record, the SAM, that we found was Edward Holden, who became director in 1881, so shortly after the observatory was established, says that the observatory was quote, built upon the spot formerly occupied by an Indian mound. So this is the only real true record we have that it was a site, at least a Western record. I'm sure Indigenous people who have ties to the land have their records. But he's also quoted as saying, "These are striking memorials of a race whose language even is unknown, and they serve to show the kind of antiquities which the young communities of the West afford. They should be sacredly preserved for present and future study."
The observatory began with the private public initiative. How long did that continue, that structure? And where were the impetuses, if there were, for federal research money to Washburn specifically?
Let's see, so Washburn specifically limited his involvement to the building, to the completion of the observatory. And he didn't, in his will, although he left bequests to a number of places, he left no money at all to the Washburn Observatory, which caused Director Edward Holden a certain amount of consternation. There are letters there where he's writing to Washburn's business manager and saying, "Are you sure that there wasn't?" So that ended with the completion of the observatory in 1882, which is also the year in which Washburn died. Washburn clearly felt that he had, at least I would read it, that he felt he had done his part, and now the university and the state should do their part. That's a very astute requirement of Washburn to have placed a requirement that the state contribute and to make sure that the observatory belonged to a university, to our university. You can look at a number of American observatories in the second half of the 19th century that failed quickly in some cases for any number of reasons, but usually because either they couldn't keep an astronomer working, who often had to be a volunteer. Sometimes private observatories were built, but with no provision for public support or institutional support, say from a university. In some cases, they had observatories, but it was very impossible to have a program of scientific research going on there. So the Washburn had hit on this kind of a partnership between a private individual and the state and the university that solved problems that had occurred. He may even have been aware, I don't know, but he may have been aware of some of these sort of dramatic failures of other observatories in the country. Federal funding wouldn't become important. That is, funding from the federal government would not have become important until the 1950s. There were private money from outside of Wisconsin. Things like from the Carnegie funding was really important for a while. A few places like that big foundation funding that is not federal in the sense of the federal government, but was the university observatories, that the university astronomers, Wisconsin astronomers, were competing successfully in obtaining outside funding for. Stebbins was particularly successful at that. But yeah, the federal funding wouldn't become important until after World War II, when the Naval Research Lab, for some reason, got very interested in astronomy and started funding some astronomers, including some Wisconsin astronomers. And then 1958, you have the formation of NASA, and of course the National Science Foundation decided at a certain point that astronomy is a priority. So not until after World War II did federal funding become a significant factor.
In fact, that's one of the interesting facets in David Sobel's book, The Glass Universe, is learning about the Harvard Observatory. And really the innovation that happened there was the result of Henry Draper's widow, who took an interest in extending her late husband's work and funded the observatory for many years. But really, that's what the observatory ran on at Harvard, was this private money. It really wasn't until much later in history that national science became a focus in the United States.
I think Jim and Kelly will be happy to chat a little more while they're signing copies of Chasing the Stars, which, as I mentioned at the outset, that's just out that door, and there's a table with the books down to the left. And I guess just thank you all for coming again today. This was nice.
Thank you, Doug.
Thank you.